Dear students, I am Dr. Ravindra Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamni Devi Group of Institution Indore. I want to teach you through this lecture 3, solution of differential equation of first order and first degree by exactness. So first of all, we understand what to mean by an exact differential equation. The equation is of the type m dx plus n dy equal to 1 is called an exact differential equation of order 1 and degree 1 if and only if del m upon del y equal to del n upon del x, where m and n be some function of x and y. It is an exact differential equation, differential of some function of x and y. Let we come to verification for this exactness of differential equation. If the equation is of the type m dx plus n dy equal to 0 is called an exact differential equation of order 1 and degree 1. Then m dx plus n du y equal to du, where u is some function of x and y. That is, it is an exact differential of some function of x and y. Let me suppose that that function is u. So but we know that what to mean by exact differential of function of two variable, du equal to del u by del x plus dx plus del u upon del y into dy. Hence, therefore this expression and this expression both are to be same. Okay, that's why we equate them. M dx plus n dy equal to del u by del x of dx plus del u upon del y of dy. Therefore, on equating the coefficient of like powers on the both side, we get m equal to del u by del x, n equal to del u upon del x. So that is, you will get the desired condition of exactness. For this, you are finding again the further differentiation. So differentiating m with respect to y partially and differentiating n with respect to x partially. So the differential of this is del u upon del x equal to del by del x and del u by del x delta 2u of del x del y. Now we know that one very important result, if u is a function of real variable, then in this case the value of the second order derivative obtained by this way or obtained by this way by changing the order of variable, then the answer remains unchanged. Hence from above we can say that both the expressions are same, that is del m upon del y equal to del m upon del x. That is, hence proved the exactness of first order and first degree differential equation. Now I will tell you the step of solving this type of problem is, the formula is integral of m dx by keeping y as constant plus integration of all those terms of n not containing x integrates with respect to y and equal to c as constant of integration. Let me see an example. By this method I am going to explain you. Then we come to the method of solving non-exact differential equation in the same lecture. So show that the question is asked in this way. Show that the equation this is to be exact and find its solution. If it is exact, then you are in that position to solve it. For this, first step is on comparing with our standard pattern as m dx plus n dy equal to 0, that is by taking the coefficient of dx as capital M and coefficient of dy as capital N. That is m equal to 2x cube plus 3y and n equal to 3x plus y minus 1. Now on differentiating m partially with respect to y, this gives to you differential is 3, and differentiating n with respect to x, this gives to 3. Both are same, hence therefore the given equation is exact form. Therefore we write the general solution as integral, first by writing the formula m dx by keeping y as constant, all terms of n not containing x dy equal to c. Now on putting the respective value in this formula as, this gives to you 2x cube plus 3y of dx, and inside the another integral terms y minus 1 of dy equal to c. Try to integrate this. what is the integral of first term? First term integration is 2x4 upon 4, then 3xy, and then this term integration is y square upon 2 minus y. That is, the answer is 2x4 upon 4 plus 3xy plus y square upon 2 minus y equal to c, where c is constant of integration. Now we come to the method when the equation is not given in exact forms. So when the equation of the type mdx plus ndy is not exact, then we multiply this type equation by some function of x and y or by a suitable factor so that the equation become exact. Then this factor is called an integrating factor. Now various rules are available for obtaining integrating factor. Through this lecture 3, I am going to discuss first 2 rules, and then in the next lecture we'll discuss the remaining 2 rules here. So first rule says that when the equation of the type mdx plus ndy is not equal to 0 is not exact, and m and n we both are homogeneous function of x and y, then you understand that this rule is applicable. And then the condition is mx plus ny multiply m by x multiply n by y and then adding up, and then if it is non-zero, then its reciprocal will be your integrating factors. Let me come to an example. This is supposed to be your example. The problem is solve this equation x square y minus 2xy square dx minus of this. So then on our first duty to compare on the both side with the standard forms mdx plus ndy, find out m and n, and then differentiating m partially with respect to y and differentiating n partially with respect to x. So m का y के रिस्पेक्ट में डिफरेंशिएशन होगा आपका x square minus 2 to the 4xy, and the differential of n with respect to x is first term is minus of 3x square minus 1 plus, then differentiation with respect to x is 3 to the 6xy. Therefore you will understand that clearly both are not equal. That's why these two derivatives are not equal, that is the equation is not exact. Now our duty is to apply the rule 1 of this, because for this we check it whether m and n both are homogeneous functions. So let us see here, x square plus y, first term having degree is 3, second term having degree 3, that's why m is homogeneous function. Then we come to n, first term is 3 and second term is also 2 plus 1 is 3, that is m and n both are homogeneous functions. So that's why you are able to apply rule number 1. So according to this, multiply m by x, n by y and add up adding them, so you get it gives to you x square y square, which is non-zero, hence the integrating factor is reciprocal of this. Therefore now multiply the given equation by this factor, then it will reduce into exact form. So multiply this equation by this. So first term you get 1 by y minus 2 by x dx minus of x upon y square minus 3 upon y of dy equal to 0. It is an exact equation, of course. There is no need to verify exactness condition. Now your duty is to write the general solution of given problem by using this exact equation. So first by writing formula, and then by writing the value of m, and here by writing the terms, all those terms of n which do not contain x. So it is 3 upon y of dy. So please integrate this, x upon y minus 2 of log x and 3 log of y equal to c. That is your integration is x upon y minus 2 of log x plus 3 log of y equal to c, where c is constant of integration. Let us we come to the second rule of finding integrating factor is. So when suppose your rule 1 is fail, or if your duty to solve by this rule 2, what is the condition? First condition is same as for all these rules, equation is not exact, and if it is of the pattern is f1 of xy y dx plus f2 of xy dy x dy, it means to understand that this in this problem this rule is applicable. And what is the final condition? When this difference is non-zero, then its reciprocal is integrating factor. Let us see an example. From example we illustrate this rule is, suppose this is in a question, you will, instead of verifying first rule, you will check if it is second rule is applicable by taking y is common in with the help of dx terms. So y easily taken common, here x can easily taken common, so that's why. And you also understand first rule is failing here because first term this m having degree is 3 while second term is degree 1, so that's why m is not homogeneous function, so that's why first method is totally fail here. You have to apply only the second principle here. So on comparing with these standard forms, and therefore first on checking the exactness condition, so m equal to 2xy square plus y and n equal to x plus 2x square y minus x power of y cube. Please differentiate m with respect to y and differentiate n with respect to x. so m का y के रिस्पेक्ट में डिफरेंशिएशन होगा फर्स्ट टर्म का 4xy plus 1, and similarly you can differentiate second one n with respect to x. Its differential is 1 plus 4xy minus 4x cube y cube. Therefore it is not exact because both the expressions are not equal, and we have already illustrated to you कि this question, given question can be written as of this pattern as f1 of xy y dx plus f2 of xy x dy equal to 0. That is, this is the position of applying rule number 2 because first rule is already false because this f1 multiplied by this, that is the function with dx, is not homogeneous. So what is the rule for the next step or second case is finding mx minus ny value. It is x power y4 which is non-zero, therefore its reciprocal is integrating factors, that is, or therefore multiply the given equation by this factor, so it gives to you, we get 2 upon x cube y square plus 1 upon x raised to 4y4 x power of y cube of dx 1 upon x cube y4 plus 2 upon x square y cube minus 1 by y dy equal to 0 is an exact differential equation. Therefore now you can write the general solution formula m dx keeping y constant, all terms no open, not containing else. In the next slide we come to conclusion of this. So integration of this 2 upon x cube y square plus 1 upon x power y cube of dx keeping y constant minus 1 by y of dy equal to c. So what is the differential of first term with respect to x is x की पावर को ऊपर ले जाएंगे न्यूमरेटर में तो हो जाएगा x की पावर -3, उसमें +1 करेंगे तो और डिवाइड करेंगे 2 से, तो 2 से 2 कट जाएगा तो ये आएगा 1 अपॉन पावर को प्लस करेंगे तो आएगी आपकी वैल्यू फर्स्ट टर्म का इंटीग्रेशन आएगा -1 अपॉन एक्स स्क्वायर वाई स्क्वायर, फिर इसी तरह से दूसरी टर्म का इंटीग्रेशन करेंगे आप लोग। सो x की पावर -4 है उसमें +1 करेंगे तो -3 आएगा, -3 से तो आप लोग डिवाइड करेंगे सो इस टर्म का इंटीग्रेशन आएगा -1 अपॉन 3x क्यूब वाई क्यूब और 1 अपॉन y का इंटीग्रेशन होगा y के रिस्पेक्ट में log of y, so minus log y equal to c, where c is the consequent of integration. Thank you very much.